Hello, today we're going to solve the system of equations by graphing and determine the number of solutions to the system. First, what is a system of equations? A system of equations just means that I have two equations. Could be three, usually it's two. So I might have the equation y equals negative 1/3 x plus 4, and I have another equation that says y equals x minus 4, and it asks me to solve this system. Now, when it asks me to solve this system, it's asking me what points does the system have in common, the two equations have in common. So what I need to do is, to solve it by graphing, is to graph each equation. The point they cross at is the solution to the system because it's the point that they both have in common, and typically it is a point. Usually we have a point, one point is the answer. We'll also have an infinite solution and a no solution, which I'll show you in a few minutes. But typically you have a point that they cross at. So first, when I'm looking here at these two right here, let's review how to graph them. So first, they're both y equals, so I can graph using slope-intercept form. So if you recall back to slope-intercept form, so on the first equation here, it's already in slope-intercept form because it's y equals mx plus b. My slope sits in front of my x, and my y-intercept is the b, which sits at the end. And if you recall when we graph, we take the y-intercept, 4, 1, 2, 3, 4, and then I count my slope. When my slope is the 1/3, I go down 1 because I move my y first. I go over 1, 2, 3. So just to review, when I have the slope negative 1/3, negative 1 is my y movement, and because it's negative, I go down from my y-intercept, and then I move to the right 3. Now, in Delta Math, when you're working on your assignment this week, it's going to ask you to graph 2 points. These are the 2 points you're going to graph, the M and the B, and it automatically draws the line, so you don't have to get out a straight edge and then draw this pretty line right here. It will do that for you. So you don't have to be as exact as I have to be, because if we were doing it in class, you'd have to be very exact to find that place it crosses at. So now we're looking at our second equation. So again, what number's in front of the 1? Exactly, it's my slope, and it's a 1 that's in front of my x. So here my slope is 1, which means 1 over 1. My intercept is negative 4, or my b. So I come to my negative 4, 1, 2, 3, 4, and I'm going to go up 1 and over 1. I'm going to do it a couple times. Then again, you can only do it twice on Delta Math. It's going to ask for 2 points. You're going to plot the b and then plot where the slope lands. I'm going to line it up nice and straight. Oops, I didn't do that straight, sorry. And then I see when I graph these two lines that right here, when I'm looking, oops, I forgot to put my layers there. Right here, where I'm looking, they cross right there at this point. The point they cross at, that is my solution. That is my answer. Because that is the point they have in common. So it's the ordered pair because we're on a graph, and it's always an ordered pair whether you're on a graph or not on a graph. My answer here would be 1, 2, 3, 4, 5, 6, 2. So the answer, or my solution to my system, is 6, 2. Seems pretty easy. So let's try one more. All right, so let's pick two other equations. This one says y equals 3x minus 3. And my second equation is going to be x plus y equals 5. Now again, you're going to choose how you want to graph it. I'm going to choose it, the first one, using x and y, y-intercept form, because it's already in slope-intercept form, already there. So here, my slope is in front of my x, it's 3, my intercept is what's at the end. It's negative 3. That means I'm going to move my slope 3 over 1. I'm going to plot negative 3, 1, 2, 3. And I'm going to move my slope. Because he's 3 over 1, I'm going to go up 3 to the right 1. 1, 2, 3, 1. And again, on Delta Math, you can only put 2 points. And it automatically will make the line for you. I unfortunately have to draw my line. All right, now my second equation's not in slope-intercept form. Got 2 choices. I can either A, move my equation around and put it in slope-intercept form and graph it, or B, if you recall, I can use x and y intercept. So now, x and y intercept. Remember, to find my x-intercept, I make my y equal to 0 in my equation. So x plus 0 equals 5. That goes away. So my x is 5. That means on my x-axis, my x-intercept, 1, 2, 3, 4, 5, is 5. Because remember, it's not really the x equals 5. It is the equation 5, 0, ordered pair, 5, 0. But because I'm not using it as an answer, I can just say, hey, x is 5, plot the darn thing. All right, so now for my second thing, I got to find the y-intercept. So when I find my y-intercept, x equals 0. So now I take in my equation and make x equal to 0. So now I have y equals 5. So 1, 2, 3, 4, 5 up here. And again, right here, it's really 0, 5, but we don't have to write that because it's not the final answer. So now I take my handy-dandy straight edge. Ooh, almost made my other line not long enough. And I'm going to connect my 2 points. Again, on Delta Math, it's going to say to put 2 points, it would be the x-intercept and the y-intercept. And it'll draw the line for you. And then again, what would my answer be? Exactly, where they crossed. That is my answer. So my answer is what? 1, 2, 1, 2, 3. So it's 2, 3. Pretty easy. So how do we get then? So that's when you have one solution. Because obviously 2 lines are only going to cross in one place. Or are they? So when we start looking at different types of solutions, there's 3 different types of solutions you can have. We saw 2 of them here. Sorry, I don't like that. Sorry. We saw 2 of them here where we had the one solution, because there's only one ordered pair, right? That's one solution. The 2 lines crossed in one place. I had one solution and it made an ordered pair for me. Done. Then we have 2 different types that we can see. One's called infinite many solutions, and the other one's called no solutions. So for no solutions, well, how could we not have a solution? Well, obviously, if there's no solution, our lines aren't going to ever touch. So if our lines never cross or touch, what kind of lines are they? Exactly, parallel lines. Then the other one is infinite solutions, and I'll show you an example in a moment. We have infinite, or sometimes they call it infinite many. They use both, just like we talked about earlier in the year. Infinite many solutions. Well, what would have every bitty point possible in common? It would have to be the same line. It's the same line. So when I graph it, it's exactly the same line. For these 2 here, when you do this part, when these pop up in your Delta Math, they're going to have, in your Delta Math, they're going to have equations. You can either A, graph them every time, or B, pull out Mr. Desmos' calculator. Desmos is great for this because I can see it. So that's what I'm going to do for these last 3 examples. I'm going to put it into Desmos for you. So the first one, I'm going to have negative x plus 5y equals negative 5, and 2x minus 5y equals 7. And it's going to say, how many solutions? Does it have 1? Does it have none? Or does it have infinite solutions? So let me get my Desmos calculator. I meant to put it on earlier, forgot. Come on, Desmos. There we go. All right. So now, when I'm in Desmos, right here, no, it's kind of hard to see. Is that, I don't know if that's better. A little bit better. Okay, I'm going to put into my two equations. So I have negative x, and remember the negative is the subtraction sign on Desmos, not on the graphing calculator, plus 5y equals negative 5. That's my first line. Then I'm just going to put enter, and it's going to give me a new box. That's going to be my new equation. 2x minus 5y equals 7. And it graphs my other line. So there's my two lines. They cross in one spot. So there is my solution right there. The solution to this system is 2, negative 0.6. That's my solution. And it's going to have one solution as the answer, because that's what's going to ask you. How many solutions? One, none, or infinite many. All right. So my next example. Let's get another example here. So I have, my second example. I have x plus y equals negative 7. I have negative 4x minus 4y equals 27. So again, I'm just going to clear out, and so I can type them in. So now, I'm going to type right there. I have x plus y, equals negative 7. Next equation, negative 4x minus 4y equals 27. When we look right here, the graph is on top of each other. There's no two lines. The graph is on top of each other. That means we have the infinite solutions, infinite many. Because the fact every point they have in common, because every point is on top of each other. So every point is in common. So our last and little final example, is going to be what? But I'm going to put it on there anyway. So I have negative 6x plus 5y equals 7. Positive 30x, 30x minus 25y equals negative 35. And it's going to say, how many solutions do I have? So let's put it in. All right, then my next one. Oops, sorry. Okay, so when I'm looking at these two lines here, we see they're never going to touch because they're perfectly parallel. So when I have my parallel lines, the answer choice is infinite many. You all have an awesome, awesome day, and we'll see you later. Thank you.